In part 3 of the Unit 8 notes, we are going to be looking at how to classify different types of chemical reactions. Our first type of chemical reaction is called a synthesis. A synthesis is a chemical reaction in which two or more substances react to produce a single product. When two elements react, the reaction is always a synthesis. A combination of elements and compounds can also combine to form a synthesis reaction. Here we have a generic version of what this reaction would look like. You have A plus B yielding a single product, AB. When you're classifying a chemical reaction, you should look to see if there are multiple reactants and there is only one product. So I have a few examples of actual synthesis reactions down below. Here we have aluminum plus bromine, two elements combining to make a compound, aluminum bromide. Here I have two compounds combining to make a larger compound, and here I have a compound combining with an element to make one compound. Our second type of reaction is a decomposition. A decomposition is a chemical reaction in which a single compound breaks down into two or more elements or new compounds. Decomposition reactions often require an energy source such as heat, light, or electricity in order to occur. So here I have a single reactant that is breaking down into multiple products. For our examples of decomposition reactions, here I have a single compound breaking down into two smaller compounds. In these next two examples, we have a single compound breaking down into individual elements. So compounds breaking down into individual elements. Our next reaction type is called a single replacement, also sometimes called a single displacement. They mean the same thing. A single replacement is a chemical reaction in which one element replaces the atoms of another element within a compound. Like elements will replace one another. So metals replace metals, and nonmetals replace nonmetals. So because of that, I have two versions of that generic equation here. We have element A and element B, and they're going to switch places with one another. Since they are the first element listed, this would be an example of metals switching places. Here I have X and Y switching. And since Y is the second element listed, this would be an example of nonmetal switching. So when you're looking at this type of chemical reaction and trying to classify it, what you're looking for is an element by itself, which is then within a compound at the end, and then a new element by itself. Here we have a couple of examples. In this one, I have a metal switching with a metal. So notice that now copper is by itself, and magnesium is in the compound. And here I have a nonmetal switching with another nonmetal. So now bromine is by itself, and chlorine is within the compound. An analogy for this would be if there was a couple dancing and then somebody else cut in. So now there is a new couple dancing with a new person by themselves. A double replacement is somewhat similar. This is a chemical reaction which involves two ions of the same charge switching partners to form a solid precipitate, a gas, or a molecular compound like water. Now in the previous example, we had an element by itself which would switch into a compound. Here we have two compounds, and then the positive ions are going to switch places with one another. So that's the primary difference. In a single replacement, you have an element by itself. In a double replacement, you have two compounds. In our examples here, we have potassium and lead switching places. Lead is now with the iodine and has formed a solid compound. In this example, we have sodium and hydrogen that are going to switch places. Hydrogen is now bonding to sulfur, which is going to produce a gas, so that's why this is a double replacement. And then here we have hydrogen and sodium switching places. We make a molecular substance like water. For our analogy here for a double replacement or a double displacement, we have two couples dancing, and then this time they both switch and we end up with two new couples. Our next type of chemical reaction is called a combustion reaction. Combustion is a chemical reaction in which a hydrocarbon burns and reacts with oxygen to produce carbon dioxide and water. Now the word hydrocarbon means exactly what it sounds like. It's a compound which has both hydrogen and carbon in it, and it is a type of fuel. Unlike other chemical reactions we have looked at, 3 of the 4 elements or compounds present in a combustion will always be exactly the same. The only difference is the type of hydrocarbon used. So when you're looking at a combustion reaction, you're always going to have oxygen, you're always going to have carbon dioxide, and you're always going to have water. The only thing that can change are these little subscripts down here, because you can have different types of fuel, so different amounts of carbon and different amounts of hydrogen. So you can see in our examples down below, this part of the reaction is exactly the same. Here I have C2H6, and here I have CH4. Our final type of chemical reaction is called an acid-base reaction. An acid-base is a chemical reaction in which an acid and base combine to form a salt and water. The salt does not necessarily have to be NaCl. So a salt is a term that we use for any ionic compound that would be created. An acid-base reaction is a special type of double replacement. Since we have not covered naming or identifying acids and bases yet, you can just simply classify these as double replacements. They are technically different, but for our purposes for right now, you could just call them a double replacement. So here you have HCl, which would be an acid, hydrochloric acid, and sodium hydroxide, which would be a base. They're combining with one another. The H and Na are going to switch places. So now you end up with HOH, which is the same as H2O, and NaCl. So you have some type of salt and you have water. For a checkpoint, we're given 5 different types of chemical reactions, and we're asked to classify each one. We are not going to be using acid or base, so we are simply using synthesis, decomposition, single or double replacement, and combustion. When I look at the first example here, what I notice is that there is an element by itself, and in the end, that element is now in the compound, and there's a new element by itself. That would be an example of a single replacement. In this example, we have oxygen, carbon dioxide, and water, and we have a fuel. This is different from the other examples that we saw, but we do know that the X and Y can change here, so I would label this as a combustion, since I have a hydrocarbon reacting with oxygen to make carbon dioxide and water. In this example, I have 2 elements, and it looks like they are combining to make a single product. So if I'm making just one product, that would be a synthesis. In this example, I have 2 compounds. It looks like the lithium and lead are going to switch places here because lithium is next to the nitrate at the end and lead is next to the bromine at the end. So since I had 2 compounds and the ions switched within them, that would be a double replacement. In our last example, we have a single compound. It looks like it's breaking down into a smaller compound and then an element. So since I had one reactant and I made multiple products, this would be a decomposition. So that concludes part 3 of our Unit 8 notes. In our next part, we are going to show how to predict the products for a single or double replacement reaction and also how to write net ionic equations.